cool. So we did a proof of concept project that was controlling a classroom AV system with voice. And like I said, it was a proof of concept project. We initially did this to see if it could be done. We found out it can be done. And we actually put it in a classroom to help a visually impaired instructor. Have some co-presenters. Most of them aren't here. Me, systems programmer designer at Utah State. Tyler Clare, he's our Canvas administrator, does instructional tools, and he's responsible for some of the back end on the Amazon Alexa skill that we developed. And we have a student programmer, Andrew. He's an undergrad, and he did some really impressive stuff with the Alexa programming, and I did not even know when we first started this project that Andrew is a freshman. And we actually had Amazon come out to our facility to look at our project with us and get us set up with Alexa for Business. And we were talking to Andrew, they almost offered him a job right there. It was pretty cool. It's pretty cool for him. Real quick about our operation. So we're located in Logan, Utah, about 80 miles north of Salt Lake. A lot of regional and small campuses, classrooms across the state. We're the land grant school in the state. Most of our operation with those remote sites is via video conference. We actually design and maintain a standard parts list, provide bid pricing, control system program, user interface for these remote sites. With the caveat that they use them for their distance learning rooms, for their origination, their receive rooms that have control systems. The stuff they use for face-to-face teaching, they pretty much do their own, although they take advantage of our designs and our standard parts list, and they pretty much buy the same stuff. The equipment we use for our distance learning classrooms, we actually, this is a recent change, we actually purchase this equipment at the Logan campus and we provide it to the sites. This is a really strong incentive to maintain a standard design, right? If we buy this stuff and then give it to them. So we provide, like I said, with the drawings and parts list, bid pricing. They're expected to build rooms to the standard if they use interactive video conferencing. But I mean, individual needs and so forth are accounted for. So there is some customization of the programming depending on their needs. I do most of the programming for the Crestron systems that they use at these sites. So, like I mentioned, we use a lot of programmable control systems and custom touch panels, largely Crestron. In fact, all Crestron at our facility. We do this because obviously the advantage of something like Crestron is you can control any device regardless of its connectivity. So I don't need everything to be able to reside on the network. I can control things like screens that just have relay control. I can have power on off for displays that use RS-232, even infrared control if we need to do that. So that's a big advantage to something like Crestron. So we have lots of older rooms, older equipment, all being controlled with a common user interface because the Crestron can make that possible. We do reach out to our customers, our users, to get input on what they need. I mean, we don't do this stuff in a vacuum. That could be really bad. We do things like we have an in-house, like a little in-house trade show that we do with IT. We set up like our future classroom teaching station. This is from a couple years ago. Hello, okay, I'm back. She's standing in front of a station there with a Microsoft Surface Studio, which is now our classroom PC as a standard. USB document camera and a sit-stand desk is what we've gone to for a podium. Faculty training retreats, another way we do that. We have staff that go out and work with the faculty to see how they teach, what they want to do, and see if the stuff we do is meeting their needs. We also have a classroom innovation lab. This I found out is a little bit unusual because it takes a budget to do this. So we have actually a full-time employee whose job is to manage this innovation lab. And it provides a place to prototype things like the teaching station and to show faculty some of the options like AR, VR. He's got a station set up. You can see there a picture of someone trying out the VR system. Auto tracking cameras, beamforming microphones, alternative control methods. So a place that we try this stuff out before we actually throw it in a room and scare people with it. So voice control. Why would we do something like this? We kind of have a mandate from our boss, and this is a boss over part of our operation, the part that's the innovation lab, so my time is shared. I have about 80% of my time with the normal classroom group, and the other 120% is with this development group. So that's kind of how that works out. We did this because we can try this. We have the resources to try it. Our goals are to improve the user experience and to provide options, control options for people. What can we do to make it easier to teach? Consumer technology has kind of always driven what we do in AV, at least it seems like that's the case. People have, tons of consumer technology that they're used to using, and they want to use it in the classroom to teach with, if at all possible. Voice control is no exception. So initially we did a test, and I'm not sure if you may be aware that Crestron actually has, built into their touch panels, they have a voice interface. And it uses Google Voice, and what it does is it listens to what you say to it, it sends that audio file out to Google, Google returns a text string. And so the Crestron system can be programmed to read that text string, and if it exactly matches what's programmed in it, it will do a command. And you can see there, this is actually one we deployed in a conference room for them to try. I had just said to the touch panel, I'm talking to the touch panel, and there's its text returned, and it says complete. It's processed the text and returned it. And if I had it programmed to do something when it heard that, it would have done it. You could do the simple controls that are available on the touch panel with that. As far as I know, no one has ever used it in that room. They know it's available, but if at most they've tried it and they haven't used it. So that was our initial test. That was a while ago, just to see if that was possible, if it was worth it. Kind of decided it was possible. It's not really worth it. Everyone's familiar with smart speakers, obviously, and I brought an Echo Dot with me. Hello, Alexa. Hello.
Hi.
Okay, she's awake. So my other co-presenter that I was able to bring. So this is probably the most recognizable type of smart device, AI, that's available, except maybe HAL 9000 might be more recognizable to tech people of a certain age. So these, they're designed for the home market, and they're designed to make it easy to control smart home devices, smart home appliances, lights, refrigerators, I mean all the stuff you can buy with them now, your thermostat. But they're designed to be thrown on your home network. They have no security protocols. They want to be able to detect everything else on the network. They want to be able to see it and communicate with it. So that's cool, but that's going to give us issues on our campus network. And the main issue would be we would ask IT if we could do this, and they'd say no. Not only no, but heck no. So our challenge was to integrate this into a classroom system. So the obvious way for us, because we were a Crestron operation, is to use the Crestron control systems to do this. Because Crestron is, and systems like it, are designed to communicate and control things that are not necessarily on the network. So screens that control with relays, TVs that maybe have a RS-232 commands, infrared even dumb relay controls on displays that don't have any form of external control. You could switch the relay on and off with Crestron. So Crestron will do that, and it gives you a place to control from. And also we're not going to go and replace all of our TVs and projectors and everything else with the latest and greatest because it has an interface that we can use. We're going to replace it when we have to, when it's exceeded its useful life. So here's something that lets us control what we have. And this is internet connected, and it can be programmed to do anything we need it to. So that's our endpoint for this. So we chose Amazon's Echo platform to do this. And I don't have this muted right now, so I have to be careful. When I say the word Alexa and I don't have it muted, it's going to try to respond every time it hears its wake word, which is Alexa. So I'll mute it for now. They have a well-developed developer platform and an easy-to-use API. And I'm sure you've all heard of security issues, concerns with platforms like this. What we found in looking around is that the Alexa platform is much better in that respect than others. So for example, this is muted right now, and this is a hardware mute. So I can say anything to it, Alexa, hello, nothing. It's an either or. It's either muted or it's listening for its wake word. So that's done in hardware on this device. So it's really pretty secure if you remember to mute it. Oops, back here. So, in case you're wondering about the popularity of it, latest word is that there are more than 70,000 skills, custom programs available on this platform, either that manufacturers have made or that people have written their own, or that Amazon has provided. Tens of millions of devices sold in 2018. So how many in here have one at home? Okay, half the room. How many have more than one at home? Almost the same number of people. You find out if you get one, you want more than one because you can put it in different rooms. Yeah, we have two at home, which is, it's kind of fun. I looked a couple days ago and they had a package 3 for $70, and I think even now we're selling them for $19.99 a piece, which is crazy. In your car, yes. Cool. So good artificial intelligence, and I mentioned HAL. Okay, we all know artificial intelligence from HAL. Challenge for voice control could be security that we talked about, reliability, and availability. I don't think they're as good yet as a traditional control interface, but the reliability and the conversational artificial intelligence, it really gets better all the time. Alexa, open the pod bay doors.
I'm sorry, Dave. I'm afraid I can't do that. I'm not HAL and we're not in space.
So those who are in here while I was getting set up and making sure we could hear the audio through the speaker system, I asked the Echo to tell me the value of pi to 100 digits so we could get an audio test. Then I had to stop it before it finished. A friend of mine who works in our same facility, who I kind of consider to be a Luddite, he knew to do that. So he walked into my office one day and said, Alexa, recite the value of pi to 100 digits, and then he walked out. So I still have to figure out how to get even with it. That was unpleasant. So we talked a little bit about the security. Lots of stories about weird stuff happening with people's Echo Dots and Alexa. The way that the AI is implemented and the controls that are available to us as programmers, I think, are pretty good. I don't think security should be a serious concern, and the rest of our folks don't either, about placing this in a classroom. This is a far bigger risk in your classroom. So unless you're going to have everybody turn in their phones and throw them in a Faraday cage when they walk in the room, I think you're probably okay with the dot or something like it. So the recording only happens after the device hears its wake word. And I keep muting it so I don't automatically trigger it because we'll get interrupted. It continuously records just a few seconds of audio through a buffer until it hears its wake word. And then it will start at that point, at the beginning of its buffer, send that audio to Amazon AWS, and Amazon will send back the response if there's one program for it. So And they said the Echo Dot is actually a fairly dumb device. And I'm sorry, Alexa. Alexa, I'm sorry.
That's okay.
All right, don't want to insult her. So, a bit about the pieces of a custom skill, and this is what we did. Are there any programmers in here? So I'm not going to go too much into detail on this. This is not my area of the programming. This is Andrew. This is his area of the programming. So the custom scale on Amazon's developer platform, basically it consists of a series of intents. So this is something you want to happen when you say a word or a phrase. The utterances are the phrases or the words that you say to have that trigger. The invocation name is the name of your skill. And I'm going to go into that a little bit more later because there's a way around having to say an invocation name. So, for example, when I ask this to do something, I just say, Alexa, what time is it? So
It's 3:30 p.m.
So I used the wake word, which woke it up, but I didn't have to say anything to invoke a skill. That's something that's built in. So what we want to do with our custom functions is to not have to invoke the skill name, and I'll mute this for a minute again. So ours was initially Classroom Assistant, so we would say, Alexa, open Classroom Assistant, and then at that point we'd make our requests and have it come back. So other pieces of this, the Lambda function is a cloud-based executable program that runs virtually in Amazon servers. That's the heart of what our programmer did. So Lambda function takes the voice results from Amazon and it processes them and sends command back to our system. Skill configuration ties all these pieces together, and there's a database. And the database is cool, and it's something we just started using. So we can actually store information about our classrooms in that database. So just real quick, here's Amazon's map of how this works. So the customer asks a question or gives a command, and then the Alexa identifies your skill's name, it analyzes and understands the request, and then it sends a structured response that's a representation of your request. So this is what the Lambda skill does, is it formats it, in this case, for our restaurant. So we have a very strict command set that we want to appear at our devices. The text and graphical response is what sends to our system, and it also goes, one of those responses goes back to the Alexa and is a response, a voice response for what your request was. I'm going to ignore the bottom part. That's for their visual devices, which we've not played with yet, but we have some ideas for stuff we want to do with those, the Echo Show and so forth. And a quick look at, that's a Lambda function text. And he's actually got here volume intent, volume, list of levels. Okay, so, and a little hard to read, but you can see it says volume, in other words, that's the variable, the room. So Alexa set the room volume to 50%, which is one of the commands that we could do. So, all right, so our first implementation of this, we connected directly to a Crestron control processor, one processor, using a Raspberry Pi for an interface. And the main reason we did that is that we wanted the commands to go to some intermediate device from the public network. So the Raspberry actually resides on the public network, on our public network. The Crestron resides on a private network. So the Raspberry Pi was a means of interfacing the two networks together and not causing issues. The other thing that the Pi did was it actually formatted the responses from Alexa to something that we could match with text fields inside our control processor. So it's a little primitive, actually, on the back end, but it actually worked pretty well. So there's an example what the format of the command might look like that the the control processor would see. So projector on, and then performs that command. So, as I said, lots of devices in our classrooms that are not smart home compatible, and that we probably don't want to directly write a module to control them, which we could do. We could write an Alexa skill for Sony projector because it connects to Ethernet and it has these command strings available. We actually use a lot of those. This classroom has one in it. We could do that, but it's a lot of programming. We thought if we connected to the Crestron, then we have one point of interface, and then we could do anything we want from that. So we set this up and tried it, demoed it, and it was pretty cool. And our disability resource office found out 2 weeks before the start of the semester, and they said, we have a visually impaired English instructor. Can we put this in a classroom for her? And we were, all of a sudden it was time to panic because we weren't really feeling super good about the reliability, but we went ahead and installed it and we made it work and she used it. So pretty cool, but now how do we scale this? So we tried, the next thought we had was try interfacing it not directly to the Crestron processor, but to Crestron's Fusion Cloud service. And what Fusion Cloud is, Fusion in general, is a web-based platform for managing all of your Crestron devices. And you can actually send and receive commands from Fusion to the control systems in the room. So there are basically control hooks in there, all the things that you want to do in the room, like projector on, projector off, volume up, down. All those are available in Fusion and all report to that system in real time. So if we could do that, if we could talk through Fusion, then we have one point of interface from the public network, because we run an on-premise version of Fusion. It sits in our machine room. It has one IP address. So any Alexa device we want to talk to it, we can have talk to it. We can look up the address for the particular room using Crestron's API, which they were actually very helpful with. That's treading the fine line between hacking their stuff and doing stuff you should be able to do with it. But they were actually very helpful, and they made the API available to us, which actually other developers use it, to do this, to look up room IDs and get this information in and out of Fusion. So any room on campus, potentially, that runs the same control program and is connected to Fusion, we could put this in. So that's not all we wanted to do. We wanted some enhancements. The things that would make this easy to use. I mentioned text strings, ASCII text strings. That's not really the best way to do it programming-wise. I don't want to have to put a bunch of text strings in my program to be recognized for every command. I want other values. So things like a projector on-off would be a true-false. Projector on or projector off, true-false. Volume would be an analog level, like 0 to 100%. Which source, that's an analog value, source 1, 2, 3, or 4. And also displays, 1, 2, 3, or 4, or on. So by using making those analog values available and running those through the program, we can control as many sources and displays as we want. It's scalable. The other thing we did is on the back end of the program for this, which is something we should have done a long time ago, we didn't. Because there's always a massive list of things you should be doing, and then there's a short list of things you get done, and you have to decide where that priority is. So this is part of the priority, is that there's now a setup page on the control panel for the room, and you can tell the Crestron system if the room has sound reinforcement, if it has a motorized projector screen, if it has an air media in the room, or a ceiling mounted or external document camera, or a USB document camera, you just choose. Does it have a projector or a monitor? And lastly, is there an Alexa in the room? So I should mention that the Alexa setup, all that does is make an icon appear on the touch panel, because one of the things about this, and one of the things that makes it secure, is that I cannot remotely turn this microphone on and off. I actually have to physically press the button. That is not the case with some other platforms, and I think Amazon may be that way. I think there's an external command to actually turn the mic on and off. But correct me if you know otherwise, but I think we discovered that was the case. So that's not something you want if you want people to be comfortable with it and not worry that it's going to be unmuted remotely by somebody. So another thing we did for this, so we can still and do still use text fields, but in the program, so for example, if the room has an air media or a .cam, there are actually text values. Those names are in the program for the room. And they're also associated with an input number. So when Andrew was working on this, I said, hey, can you read that text name and then which input it's assigned to, and then make that dynamic? So if the guys go in the room and they put the room together, and in one room they plug air media into 3, and the other room they plug it into 2, can we account for that? And he said, sure, I think so. And he did it. And it actually surprised me. I think we were on Joe Way's podcast, and they're saying, we want to do this. And one of the other guys said to me, oh, we've already done it. I was like, well, what? I didn't even know I'm working on it, and I didn't know we'd done it. So that was pretty cool. The last piece of this, besides the configuration, we want that configuration to be available to Alexa. I want to know if there's actually video on an input or not. So somebody plugs in a laptop and they don't have their video output activated, maybe Alexa can know if that's the case or not and help you troubleshoot. So we're able to do that also. So real-time feedback and status. So what happens is that the Alexa skill will go out when you first initiate it, and it'll request input names from the processor. Does the room have a document camera? All those things we just talked about. And the system will respond, and then it will also tell it, input 1 is PC, that's a text value, a name. Input 2's name is laptop. Input 3's name is air media. Document camera is false, so there's not one in the room. And so that information is returned to the Alexa skill, and then that database that I mentioned earlier actually stores those values. So once the skill's been initiated, we don't expect those values to change, unless someone goes in and works on the room. So those are stored and they're available to the skill. So it doesn't have to make those queries every time you ask it to do something. And this actually, when we first did this, that's what it did. And it kind of made the response a little sluggish. So you'd say, Alexa, switch to the laptop, and it would think about it. It would ask all those questions. I have a laptop, it's on input 2. And then it would say, okay. And meanwhile, you're thinking something's wrong. So being able to store those values is a big help. The other thing about this is, if you can imagine putting this in a room that already has a touch panel, that's what we do. We want the system to know if somebody's already come in and pressed a button on the touch panel. So when we were first working with this, we discovered we could actually crash the skill if it didn't know if a button had been pressed. So we want that current feedback. So it will query projector on, and projector on comes back as true. So then it knows the projector's already been turned on. If somebody requests that, I don't do anything. Otherwise, if it were a toggle, for example, it would shut it off. We don't want that to happen either. So I actually have a live demo I'm going to do in a minute, but let me play you just a quick video. This is a different room than I'm going to use for the live demo. Bear in mind that on this, I actually recorded it with an iPhone, and I recorded it 4 times to get different angles and also to record the audio so you could hear it. But all the responses are real. Let's see if I can hit the play button here. This actually works. It's in one of our engineering rooms where we just installed this. There we go. Maybe we'll get it to trigger here. If not, we'll just skip to the live demo. All right, I'm going to go on, and if we can later, we'll play this. Sorry about the moving the live input. Oh, sorry. A lot of work as an audio guy, and I would hate it if people did that to me, so I apologize. So updates for this. So right now we're working on adding this to our active learning space. So we have a room with an instructor console and 12 displays around the room. I wanted to see if Alexa could be used in there. And in this case, yeah, and so far it actually seems to simplify the operation of the room. So let me skip out here too. Show you an image of the room. This is just a little 3D we took of the room. So you can see there are flat screens around the walls. There are 2 projectors on each side. And here's an instructor station with a PC, and there's our touch panel sitting on the desk. So complicated room to operate, although we spent an awful lot of time on the user interface to make this easier to use. As easy as possible with a room this complex. So, and the scale's not going to work out too well on this, but I'll just show you this. So homepage, power, the room has 3 modes. So just to give you a quick run through, so if you put yourself in the place of an instructor, and how would you operate this room? So you see pods around the outside, they all have letter names and numbers. If I switch to instructor mode, then I'm showing my PC, I'm showing my laptop to every pod. So we go to breakout mode, and every pod now is looking at their own video source. And the pods actually have their own air media and wired input, but those are selected automatically based on who has active video. And there is a small touch panel on each table where they can choose that. So the third mode for the room is share. So it starts out looking the same, but now if I click on a pod, like pod L, then pod L goes everywhere. Pod J goes everywhere. So that's kind of the idea. It's simple, but it obviously requires training. Sorry, because this is scaled like this, I'm going to drag it back onto my screen and see if I can change this here. Okay, that's better. All right, so we'll shut the room off again, and we'll see if Alexa can control it. Alexa, ask Classroom to power the room on.
Okay, I'm getting things ready.
Okay, so it powered the room on.
Sorry, I'm having trouble accessing your Classroom Assistant Active Learning Lab skill right now.
Alexa, stop. So the risk of doing this is my test program, so it tried to do something it wasn't able to do in the connection between here and Logan. So it powered the room on, and it switched the room's mode, which was somewhere else. It was probably on instructor. It switched it to breakout, which is what we wanted to be our default configuration for the room. It did switch the instructor source to PC, so it's ready to use on PC. So if the instructor wants to show something, it's a source you know is going to be active and operational that they can use. So Alexa, ask Classroom to breakout.
Welcome to the test skill. What did you want to do?
Breakout.
Okay. Now in breakout mode.
And it says breakout mode, which we thought was really funny. There's some adjustments to do in the program. So it would have switched to breakout mode if we weren't already there. Alexa, share pod L.
I think you are asking for the song Pod Pasmenomel. Is that
No.
right?
Alexa, stop. Alexa, ask Classroom to share Pod L. That was my fault.
Okay. Sorry, I can't understand the command. Please say again.
Alexa, stop.
Goodbye.
Alexa, ask Classroom to share Pod L.
Okay. Sharing Pod L.
So lots of moving pieces here, and I didn't mention that this is still being developed. This is running on a test processor in my office in Logan, Utah. I'm logged in to our campus VLAN so we can see this, which is an X panel that's tied into that processor, control panel for it. The Echo is talking out to Amazon servers through our account, talking to our skill, which then talks to the processor up in Logan. And then it sends voice responses back to us here. So the first time we tried this outside the state, we were amazed it even worked. Like, how can this even work? But it's really pretty cool that it even works. The mistakes are because that you saw is because once I forgot to invoke our skill, which I mentioned, I have to say the name of the skill, which is Classroom. And I have to make sure it can hear me and understand me. There actually is a little voice remote for like live echoey rooms like this. I could hold a voice remote for it, which would make it easier for it to hear me. So just some of the things. So my point with this was that we were in breakout mode, but I asked it to share a pod, and I mentioned that to do that, we have to change room modes. So the Alexa skill is actually performing a macro. It doesn't need to know, we don't need to know or tell it to change modes and then do it. We just asked it to do something and it did it. So that, we think, makes the room easier to operate. So the instructor can say, I want to share that pod, and it's just going to do it no matter what you're doing. Alexa, ask Classroom to show Air Media.
Okay.
So again,
I switched to the Air Media, but it doesn't appear to have video. Check the cable, or make sure it's turned on.
So that was my holy grail for this. So it actually went to the processor and said, is there video there? And the processor said, no, there's not, because this processor is just sitting in my office with nothing connected to it. So it says, oh, there's no video, I better warn. So it brings up the warn application. And it also changed modes back to instructor and selected the source. So again, shortcutting the steps of changing modes and taking what's a complicated touch panel. And I will mention, this touch panel took like 2 or 3 months to go back and forth with the users and have them give input as to what would be a good way to do it. So here, what we thought was as simple as we could make it touch panel, we've actually made it simpler by adding the voice control. Kind of fun. Then that's in the real-time video feedback. So the test for that, and on the video it would have showed you just would have seen the screens, going up and down and so forth. And in that room we had video on Air Media and PC, but we did not on the laptop. So I asked it to switch to the laptop, and it switched. And you can see on the touch panel that the video indicator, there's a light on the panel that's showing a color other than green, because there was no video, and it told me, I don't see any video, check the cable. So that was the important part to us, is make sure that would work, and we got that part working. So back here to this. I think I need a new laptop is what I need. So my controls have disappeared. Now it's just my laptop complaining. Okay, there we go. So what do we want to do with this next? We want to be able to dial the help desk. And actually, we tried this earlier. A couple of guys are in here. Let's see what happens this time. Alexa, dial help desk.
Calling help desks work.
And they don't know I'm doing this. See if she answers. She may be gone for the day.
You've reached Terry Gibbons. I'm either away from my desk
Alexa.
or on the...
Hang up. Well, that's unfortunate. I could have said, hey, we need help with our laptop. Where are you? We're in Las Vegas. Hard Rock Hotel. Can you send somebody down? So this is a feature of Alexa for Business, a SIP dialer.
Alexa for Business is an AWS service that
Alexa.
provides the management tools to make it
Alexa.
easy for you to use Alexa
Stop.
to voice enable your organization. Your employees can use the Alexa.
Stop. Like I said, the risks of leaving it unmuted when I talk about it. So the SIP dialer is a feature of that. So we just have a phone book in our app, and we have our office manager's phone number in it because that's who we've been testing with. So it would have really annoyed her to get a call from Las Vegas. It's too bad she didn't answer. But but you can see it, and I was surprised it worked from here. Again, one of those things that you're like, cool, it works anywhere. And this is one of the things that I would suspect that Amazon will start charging for this. Right now they're not. This is just part of the package. And they're going to figure out how cool it is and that people will pay for it, and they might start charging for it. So a feature that's built in, I have next step because when I wrote this slide it wasn't working, and it's working now. I didn't know if I could demo it down here, but I found out today it actually worked. So that was cool. Alexa voice appliance. So mute this again. So Alexa hardware appliance, a voice appliance is a software-only voice processor. And these are available as developer kits that people can go and get these to mess with and build these features into their own devices. So we want a voice appliance running on like a Raspberry Pi or some external device, and then we can take audio inputs and outputs to it. So instead of now using the microphones on the device, I can use beamforming microphones in the ceiling. I can use PA speakers and hide the hardware somewhere where instructors who are nervous about these don't reach up and unplug it, which has happened. Yes, and see, I would suspect people like Crestron and so forth would do that, but they haven't done it yet. I can only imagine that they're working on this kind of stuff in the back rooms. So, but yeah, sitting in a rack, where you don't have to worry about it, just works. Teaching applications. There's a big opportunity here for content. And so you can request information from Alexa now and you get Wikipedia entries and things like that. So our physics department wants to build their own. So you make a request to it, you ask it for information, and it goes to their database and pulls up their curated content and then replies with it. So that's something that's actually in the works. They came to us when we found out we did this, and they want to do that. Video conference rooms, this is our next one. We'll just add controls for interactive video conferencing control, which is very simple. Okay. Compared to the active learning space, it's a super simple addition. Tie into LMS and central user authentication, so a person can log in and they get access to their device in their room. And then maybe expand to other platforms, like Google Home or Apple or whoever else that has a software developer kit available. So that's it. Any questions? Yes.
Our networking folks are really not happy about us trying to bring these consumer devices on campus. How did you engage with your network?
Well, we used to be part of IT, but we're not anymore. We're in one of those departments that split off again, but we have a really good relationship with them. And so we had, in the past, we were working with them on things like Apple TV, where they have to take it and they have to make certain rules, put rules in place for them so they don't cause issues. This is really no different than that. And then, like I mentioned, for us connecting to a single device, a single point of entry, which is our Fusion server, then that solves a lot of those problems as well. And the biggest thing is communication, I think. They know what we're doing, and they feel like we're communicating with them, we're kind of part of it. Anything else? So I've actually used up every last minute of our time, so. Well, thanks.